Hey y'all, hey Data Talks crew. So I'm back. I actually got a viewer submitted question request that I thought was pretty cool. So they had sent a data set and some analysis that they had done on this data set, and they asked me to review it. And I thought this was kind of cool. I thought what would be even cooler is to kind of teach you all some tools to teach yourself, which is just new, which is basically like, hey, let's revise this a little bit using ChatGPT. So I'm going to try as best as I can to go ahead and use ChatGPT to revise this and yeah, see how it works. And so, as a caveat, it's important to understand the concepts and the fundamentals here. So if you don't understand the concepts and the fundamentals, sometimes ChatGPT can lead you astray. That being said, once you do know them, you can spot when ChatGPT offers incorrect suggestions and errors, and you can spot when it offers you good stuff. So it can use it as something that saves time instead of something that creates hallucinations. So let's get started. So this data set is it's from Scheme, one of the viewers, and it's from caffeine to cocaine. So basically, these Bolivian farmers, coffee farmers, have been switching to more profitable crops, coca leaves. So that's the thesis behind this. They got some data. Some of the data was in already a data set that they had, which was great. And some bit of the data that they actually had, they had to manually create a table for. And I have the data that they didn't manually create the table for, but the data that they manually created, I actually didn't have. So you can see the data that they manually created. It was down here. It's not big. So what I would normally do is I would take this data, I would copy it, I would, make some edits to it. It wouldn't take me too long. But what I could instead do, and I already got this started over here, as I went into ChatGPT and I was like, hey, transform this into a CSV. And it's just kind of wild that it transforms the full thing into a CSV. So I was able to take that CSV, copy it, throw it into here, and allow me to get started on doing the data science stuff much faster. So kind of cool. So let me show you, roughly speaking, what was done with the initial analysis. So we got the initial data. We looked at it. We looked at the data types, roughly speaking. Look, I would normally do a .info here. It is here, perfect. So do a .info. I would also do a .head as well, just generally speaking, to just kind of look at the data just a little bit, but that's totally fine. We plot a line chart of how much coffee production has gone up. Cool, super awesome. And then there's cocoa data, which this is the data that ChatGPT made, and they didn't make it, but they turned it into a CSV, which is great. They plotted it here. One thing that you'll note here is that the tons of cocoa production is much less than the tonnage of caffeine production. And without knowing the amount of acres each takes to produce, it does lead some skepticism as to, okay, it's 213 tons versus what is thousands of tons, because this is also tons, production in tons. And a metric ton and a ton are roughly the same. I'm not sure if this means metric tons. I would need to look at the data itself. But, there's some skepticism that I have here. And it's also a little bit of domain knowledge that I lack. And, I could ask ChatGPT, how much, how many acres does it take to grow 1 ton of coffee versus how many acres does it take to grow 1 ton of coca leaves? So, I mean, I may as well do it. Um, how many acres does it take to grow a ton of coffee versus a ton of coca leaves? I don't know if it knows this. We'll see if it does know this, but I'll just spin this question up and go back to looking at the data for just a minute. They plot this graph as well, which is interesting. So looking at this graph versus this graph, note that this graph is for a much longer time frame, and this graph, which is of the coca leaves, is for a shorter time frame. They merge these two graphs together, and the combined data is here, which basically shows some interesting trends. Yes, it does seem like the cocoa production has increased and the coffee production has decreased from the start. There's a little bit of leveling off and stuff like that. So that's kind of interesting. Let's see what ChatGPT has to say. So coffee is 1 or 2 tons per hectare. Okay. And coca depends on the region. It's 2 tons per hectare. So, so based on just sort of like initial spot analysis, like the amount of growth from these metric tons doesn't seem to constitute a massive change. Like this looks like a small change. It doesn't look like a massive change. Let me also do one more thing. Uh, Analyze this data set. This is also, I know this seems like real cheating here, and maybe it is, but you'll be surprised at how well this can do. So like based on my spot analysis, just looking, with some eyes and not looking into the data sources themselves, I've got questions. Like, are these, it also says potential metric tons instead of tons. So is there a transcription error? Is this actually supposed to be 1,000 times greater or 100 times greater or something like that? Because that would make more sense in terms of the shift over in production. Not exactly sure. They changed the data a little bit and basically here. So one thing that I would like to do is I would like to actually, assuming that these things need to be are in not in the correct exact, assuming that this needs to be 100 times greater or something like that, maybe the data was transcribed incompletely, or maybe this isn't exactly metric tons or something like that. What I would do, like, let's say that this was 100 times bigger. I would look at the two charts of these two things together. And I know I've already skimmed over the rest of this. There aren't these charts. So I would plot those charts. Now, maybe let's go over to ChatGPT because this is just pretty cool. So yeah, I mean, it's kind of cool. Like the area has a notable rise, slightly decrease in these times. The metric tons of potential has increased, reaching in 2021 and 20, yep, pretty cool. Trends in coffee, comparison between cocoa and coffee. They produce significantly more, however, the gap between has reduced. Okay, well, I mean, that's not. So it's like, it's all right. It doesn't necessarily tell us exactly what we want, but it gives us like some pretty cool stuff, just sort of initially, sort of showing initial trends. I bet I could go ahead and ask, the initial question here of ChatGPT and see what it does. But let's not cheat too much. Let's instead ask it to, given this data, how would you plot the um, plot the line graph of the tons of coffee and cocoa production over time. Now, one thing that I want to do is I want to ask it to normalize. Please normalize the data. So let's see what it comes up with. Now, again, the reason why we want to normalize this data, generally speaking, is because otherwise we're not going to see any of the fluctuations in the metric tons of the cocoa production because it's going to be so small relative to the coffee production. So the way that I would generally do this is I would go ahead and I would check out my Seaborn tutorials. Seaborn is an awesome tool for just doing some quick and dirty plots like this. Once you do the plots, I would probably, even before the plots, I would just normalize it. I'd probably do a lazy form of normalization just initially. You can use a normalizing function that you'd get from either Seaborn or from, I think even Pandas has it, maybe like a pd.normalize. Or maybe not. Or I'm not sure exactly why my autocomplete isn't exactly working at the moment, but the the other way to go ahead and do it is use matplotlib is basically what I would do. So let's kind of just check this out. Like let's say you weren't super good with plotting. Like what do they give to you? So we import pandas, we import matplotlib, we create the data, we normalize the data, which is pretty cool. Okay. And then we plot it. So let's try this out, see how this works. So my question to you is like naively, what is wrong with this? Out of curiosity, just looking at this pretty quickly. We don't have a DF. Our data is actually in a data frame called combined. So I'm just going to be pretty lazy and call DF combined. And of course, you want to delete the explanation of the code that's below it. Okay. Yeah, I don't, I mean, it's kind of cool, right? So yeah, so that's pretty interesting. Like, look, I mean, the normalized versions of these two curves looks like there is something going on, in my view, right? There definitely seems to be a little bit of a lag behind coffee production and coca leaf production. And perhaps offsetting them by a bit might go ahead and give us the results that we want. But let's continue on. Let's kind of look at the rest of this notebook. So the analysis, we do a correlation analysis at first, which is fine, and then they do a heat map of the correlation matrix, which is right down here. Okay, pretty cool. And then they are also doing correlation of year as well. So y'all might wonder here, okay, correlation is kind of cool, but what does correlation mean in this case? So what correlation would mean in this case is that an increase, I think it's a fairly good measure, a normalized increase in each of these, a scaled increase in each of these corresponds to either a decrease or an increase of them as well. So my only thought with this correlation matrix is that I might be tempted to look at different types of correlation. So instead of the Pearson R, I might be tempted to do the Spearman correlation. So let's say you wanted to do that and you didn't necessarily know. You could ask, what types of correlation do I have access to from, you could just paste in this exact thing. The correlation function of a of df dot core. See what happens. I just think this is pretty cool. So right, they talk about this, which is the Pearson correlation, which is the linear relationship between the two data sets, which I was talking about. There's Kindle for ordinal association, which is sort of depending on if if they're ordered or not. And then Spearman, which is rank correlation, which is kind of the one that I would have actually been curious about as well, sort of looking at the Spearman correlation. And it literally tells you how to do it. So I can just copy in method equals Spearman as well. you know, just in case. Oh, whoops. So just in case you want it to do any coding, you can check this out. And this is going to be different. And so, for example, we've got this. It's going to look ever so slightly different. Oh, right, we've got the normalized production. Oh, that's kind of nice. I almost want to delete the old columns here. I didn't realize that it actually added columns to our data frame. Okay, pretty cool. So, yeah, you'll see a different type of correlation that's sort of displayed here, which is kind of cool. So I would look at both of these types of correlations. I think that the original correlation that we had used was totally fine as well. I just think that I would have been curious as well to look at what the Spearman correlation was. And now y'all can sort of figure it out on your own too. Some visualization of the outputs. Okay, yep. This looks more like prediction stuff. So we decide to do prediction using linear regression. So linear regression, awesome tool for predicting things. Who could actually show me some stuff that might be better or any thoughts as to what we could do to make this better? My thought here is that I would specifically So I would change a couple of things here. So I believe that we're using every single column except for the coffee production in tons. Let me go ahead and reset the combined matrix as well. So I believe this was here. There we go. So, yep, I reset that. So we're using every column, excuse me, we're almost done basically with this. This is the last little thing. So we're using every column except for the coffee beans column. So what are the columns of this combined matrix? So we have year, hectares, metric tons, and then coffee bean. So do you want to be using year here is a question. And if you use year, do you want to be using year in the sense that do you want to be using it as a sort of a linear int input, or do you want to be using it as a categorical feature? If you use it as a categorical feature, what do you need to do? You need to make dummy variables for the categorical feature. Hectares and then potential metric tons. What's the problem with using these just straight out of the book or straight out of the gate? The problem is that they're not normalized. They're not actually standardized. And generally speaking, for linear regression, which assumes normally distributed inputs, you want to be standardizing the data. And we don't have anything that standardizes the data. So I would suggest both of those things would be pretty awesome to go ahead and do, right? If you wanted to use linear regression. The other thing to do, which could be nice, is the predicted value for coffee production is for blah, blah, blah. So it really, right. So the idea here is there's a couple ideas. Do you want to use this as a predictive function, or do you want to use this to do something like causal inference to see actually what the difference in the function, or to see actually what the causal relationship between increased cocoa production and coffee production would be? And so these are all questions that I would ask. Given that we are on a little bit of a time crunch, let's go ahead and try to make the changes to this. So let me go back to ChatGPT. Let's try to do this with ChatGPT as best we can. Um, so we have this. Instead of plotting the line graph, let's go ahead and ask it to make a linear regression. Please do a linear regression from all columns to predict coffee. Let me make it a little bit nice here. Coffee production in tons. I'm actually curious at this point to see whether ChatGPT is able to sort of do these things that we would consider common sense. Okay? Yeah, it uses linear regression. It makes the array of all of the data, which we have as well. A little bit lazy. Yeah, it's just going to actually type it out. Tragically, it makes the output, it fits, and it interprets. Okay? And then, yep. And then you can see how it would do this here. So it actually makes the exact same mistakes. Okay. Sure, sure, sure. Yeah. It makes the same, maybe not mistakes. It makes the same problem. It has the same problems that I would have put at. So let's try to correct it. Um, instead of using years as, let's make it easy. Years, right? I think it was capital years. Year as a linear input. Please make it a categorical one. Let's see if it's able to do that. Yep, one hot encoding is that's exactly what making a dummy variable would be. And fortunately, it doesn't just actually do that, which is great. It's going to type all the data out once again. I apologize. Generally speaking, you would just tell it what the columns are instead of the full data. So, which we can change, but we've already gone so far. Oh, and actually this time it makes a data frame, which is kind of interesting. One hot encodes it, which is exactly what I would do. So get dummies. Yeah, pretty good. And let me ask it the final question that I would ask, which is, can you standardize the um, other covariates? Can you standardize the covariates and the outcome variable? Please. And let's see if it is able to do this as well. And we can plug this in and kind of show what I would do. So, yep, mean of 0, yep. So, I mean, it literally, yeah, and use the standard scalar. That's exactly what I would do as well. So, I hope that this kind of makes this whole process seem a little bit less intimidating. It's taken a lot of what the data science job was a lot of things. One, it was understanding the data, which is great. That's exactly what you want to do, and sort of understanding the principal concepts behind it. And then two, it was, yeah, beautiful. And two, it was also understanding or maybe not understanding the libraries, memorizing the libraries. So I'm just going to be lazy. I'm just going to copy this full thing in. We won't even use the data that we had here. What is really awesome about ChatGPT is that it allows you to skip one of those steps, generally speaking, which is memorizing the libraries. So we can do this. And yeah, we've got many different coefficients as well. So remember the coefficients of the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. These are all coefficients that are from the year itself. So the categorical year of, just sort of showing what that is. I mean, it's a little silly in this case. And then you actually have the correlation coefficient for the hectares um, uh, of cocoa leaves that are being grown versus the hectares or versus the actual total number of cocoa leaves that were being grown. And so, you know, it's yeah. You'll notice something about this is that these coefficients, at least down below, are actually positive. So I mean, honestly, you know, it's yeah, it's a little bit silly. At this point I would be like, okay, well, let's take the year and like I would probably just take the year out. I think that this is much more of like a time series. I wouldn't use linear regression generally speaking for this. This definitely seems more like a time series data rather than a non-time series data. So actually what I would do is instead of including the year, I would include the previous year's um, consumption instead of the year at all, which basically is it's going to show that autoregressive idea behind it because even using the years linearly is kind of strange, and using the years as because this is not we're not actually doing prediction in this case. This would not generalize at all, and using the years as categorical stuff is also a little bit strange as well. So maybe we can try this one thing. Um, Instead of using the year data, can you use the previous year's coffee production as an input to predict the next year's? So maybe I would do something like this. And so again, I guess what I was saying is like, look, it takes away a lot of the memorization part of data science and it puts in a little bit more of the like being thoughtful about it. So hopefully this has been useful. I will cut out a little bit of waiting for ChatGPT in this case. And yeah, And yeah, I'll sort of show you what the finalized result is right after I'm done. Basically got back with ChatGPT. They did nothing super simple, or they did stuff that was pretty simple. They used the shift function. They included the lead coffee production as the final covariate. I can show you what the results look like over here. We've got coefficients that are negative in terms of hectares of cocoa cultivation, and positive in terms of the autoregressive effect of lagged coffee production. What I would suggest is a little bit of regularization, as well, as these are definitely correlated with each other, the potential as well as the hectares. So you should probably get a little bit better interpretation of the coefficients based on that. Again, if what this is basically trying to do is trying to do causal inference, my suggestion, if you're trying to do causal inference, is not to use linear regression at all. It is instead to use the parametric G formula, which I have some awesome videos on, which you can check out in the description of this one. So y'all, hopefully this has been helpful. Hopefully it has shown you like a cool new way to do data science just with like the aid of ChatGPT. And yeah, I can't wait to be doing more of these. If you have any videos or if you have any data sets that you want me to be checking out, please send it along. And yeah, I'll see y'all next time.